This is part 2 of section 4.3. We want to find the trig values, all 6 of them, for an angle whose ray passes through this point. So 5, -5. The first thing we need to do is to calculate our radius. And this is the square root of x squared plus y squared. So 5 squared plus -5 squared, which is the square root of 25 plus 25, which is the square root of 50, which simplifies to 5 times the square root of 2. Okay, so let's find sine first. Sine of theta is y over the radius. So -5 over 5 times the square root of 2. Okay, I'm going to simplify this very quickly by dividing top and bottom by 5 to get -1 over the square root of 2. And then if you multiply top and bottom by the square root of 2 to rationalize it, you get negative square root of 2 over 2. And then its reciprocal function, cosecant. Take the reciprocal of this to get that it's negative square root 2. Now cosine of theta is x over the radius. So 5 over 5 square root 2. And then if you reduce the 5s, you get 1 over the square root of 2, which is the same as this except for the minus sign. So once you rationalize this, you get the square root of 2 over 2. And therefore, secant of theta is the reciprocal of this, which is the square root of 2. Now for tangent. Tangent is y over x, so -5 over 5 is -1. And cotangent of theta is x over y, so 5 over -5, which is just -1. And the reciprocal of -1 is -1, so that makes sense. Okay? Now let's do the same thing here where our coordinates are negative square root of 5 and negative square root of 11. First, to find r, we take the square root of, and we're going to square each of these. So negative square root 5 squared plus negative square root 11 squared. This gives me the square root of 5 plus 11. Square root of 16, which is 4. So our radius is 4. So now let's start our trig functions. Sine of theta is y over r, so negative square root 11 over 4. And its reciprocal function, cosecant, would be -4 over the square root of 11. And rationalize this, multiplying top and bottom by the square root of 11 to get your cosecant value of -4 square root 11 over 11. Now cosine is x over r, so it will be negative square root 5 over 4. And its reciprocal function, secant, would be -4 over the square root of 5. Multiply top and bottom by the square root of 5 to rationalize, and you get -4 square root 5 over 5. Tangent is y over x, so negative square root 11 over the square root of 5, negative. And so that ends up being positive. Multiply top and bottom by the square root of 5. And you get the square root of 55 over 5. Now the square root of 55 does not simplify, so this is my answer. Now let's do cotangent. And it is x over y, so I'll have negative square root 5 over negative square root 11, and again that becomes positive. If we multiply top and bottom by the square root of 11 to rationalize, we get the square root of 55 over 11. Okay, so now that we have a relationship between x and y and the radius, and you know the radius is always going to be positive, so that doesn't really change the sign of your trig function. Okay, we need to remember where, if we know what quadrant our end point is, our terminal point is, then we know the sign of our trig values. And this becomes very, very important, okay? So, since we know our x and y determine the sign of our trig functions because the radius is always positive, we can figure this out. In quadrant 1, our x and our y, they're both positive. So everything we deal with, our x, our y, and our r, that's positive. So that means all of our trig functions are positive if our terminal point is in quadrant 1. Now, if our terminal point is in quadrant 2, our x values are negative, our y values are positive. Now, sine is based on y, and y is positive, so sine is going to be positive. Since cosecant is the reciprocal of sine, it's also positive. Now, everything else, cosine, secant, tangent, and cotangent, they both involve an x value. And since x is negative, those values are going to be negative in quadrant 2. Okay? Now here in quadrant 3, both x and y are negative. So sine, cosecant involve using a negative value, so they're going to be negative. Cosine and secant involve an x value, so it's going to be negative. But a tangent and cotangent use both x and y, and since they will be dividing, you end up with a positive answer. So in this quadrant, tangent and cotangent are positive, and those are the only ones. And then similarly, here in quadrant 4, we have a positive x and a negative y. Since these have opposite signs and we're doing a division, cotangent and tangent are going to be negative. Sine and cosecant need this, so they're going to be negative, but here our x values are positive, so cosecant and secant work. Now, so that's the explanation of it. If you can remember that, you don't have anything to memorize. Just if you have an understanding of it, you can build this yourself. But if you just want to remember the easiest way to do this, concentrate on, don't worry about the reciprocal functions. So we're just going to go sine, cosine, and tangent. Okay? And think of it this way. All students take calculus. And this will tell you which of these is positive. In this quadrant, so you're going in order by the numbers of the quadrants, all of them are positive. Students, you have your S, and the S goes with sine. Sine is positive, and then its reciprocal function will also be positive. Take, T for tangent. That one's positive here, and C goes with cosine, and that can help you to remember which is which.